done.
Okay, we're graphing
But it's finally getting better. It still looks awful though.
Yeah, it is. I'm not gonna lie. I'll be honest.
y equals 2 to the x plus 3, and y equals 2 raised to the x plus 3, right? So let's just start with what we often do. Our basic function is y equals 2 to the x. So x value is -2, -1, 0, 1, 2. Give us y values 1/4, 1/2, 1, 2, and 4. Okay? So by common sense, what would
We'll add 3.
y to the 2 to the x, y equals 2 to the x plus 3 be? And it's exactly what Jaheen said. We add 3 to the value of y, right? And this is because of the order of operations. If we're evaluating this for one of these values of x, we're going to get this. And the first thing we're going to do in order of operations is we exponentiate before we add, right?
Yeah.
And we haven't talked that much about order of operations because people seem to be relatively good with it. But so we have then -2, -1, 0, 1, 2 specifically. When x is -2, 2 to the x is 1/4. And then 2 to the x plus 3 will be 1/4 plus 3. So we get 1/4 plus 3, which is, surprise, 3 1/4, which we might well, to operate on it, we might well want to write as 13/4, depending on what we're doing with it, okay? If we're going to do arithmetic with it, we probably want to do it as an improper fraction rather than a mixed number, depending on the kind of arithmetic. If we're graphing it, 3 1/4 is convenient, right? So it depends what we're doing. Anyhow, then on each of these, we're going to add 1/4, or 3, so we get 1/2 plus 3, 1 plus 3, 2 plus 3, and 4 plus 3. So that's 3 1/2, which is 7/2. This is 4, this is 5, and this is 7. And of course, we could construct the graph, and if we did, every y value would be 3 greater than before, so the graph would shift 3 units upward, right? So let's go ahead and do that. We've got the graph here. And I'm not going to actually plot the points, I'm just going to draw the general picture of the graph. But what we do then to get this graph is we take the original graph and we raise it up 3 units. Now, this is 1 unit here, so we can see how big 3 would be. It's about this far, maybe that's a little too far, but you see we take every point and raise it that far, and we get a graph that has exactly the same shape, but it's 3 units higher, right? So that's a vertical shift of 3 units. So this is a vertical shift of 3 units. Okay, the other thing we can see is this is, if f of x is 2 to the x, then what we're graphing here is f of x plus 3, 2 to the x plus 3. Now, if we want to graph 2 to the x plus 3, we want to get the y values that we would get here. And we're going to revise our x values so that we get those values. Okay? And this is something, people did pretty well with this on the test overall, but we really now need to get really good with this so we can apply it to a wider variety of functions. So our y values, we want to get 1/4, 1/2, 1, 2, and 4. Same as we get over here. Well, in order to get that, we have to be feeding different numbers in. If we feed -2 in here, we get f of -2 plus 3 would be, f of -1 would be 1/2, right? okay?
So.
Now, negative 2 plus 3 is 1, but yeah, we'd get 2.
So the x
We
plus
wouldn't
3.
get 1/4, right? In order to get 1/4, we have to be, our x plus 3 has to be what? Negative 2, right?
Yeah.
Okay, 1/4 is 2 to the negative 2, so whatever number we have for x has to give us negative 2 when we plug it into the x plus 3, right?
5.
So that would be negative 5. Okay? So let's write out why that is. F of x plus 3 is 2 to the x plus 3, right? Well, in order to get 1/4, x plus 3 has to be negative 2, right? Since 2 to the negative 2 is what gives us 1/4, right? Well, if x plus 3 is going to be negative 2, what does x have to be? Negative 5, right? So the question we can ask ourselves is, if x plus 3 is going to be the number that gives us 1/4, which is negative 2, then what does x have to be, right? Okay?
My thing is when we comparing those two functions, we still have to make sure that the y value stays the same as the first function.
Well, that's the way we're going to understand how this graph shifts.
Yeah.
And that's what I've told you you need to do in order to understand the shifting you get when you replace x by x plus 3 or by whatever.
Okay.
Okay?
I did so much of the wrong.
So, we want to get the same y value that we got over here, which means the x plus 3 would have to equal negative 2, right?
Mm-hmm.
Because we're raising now 2 to the x plus 3 power. Okay?
Basically, x is.
Which means x has to be 3 less in order to give us the same value. Which means then that we'd have to evaluate it negative 4 here, and negative 3 here, and negative 2 here, and negative 1 here, and we can verify that. If x is negative 4, then 2 to the x plus 3 would be 2 to the negative 1, which is 1/2. We get what we say we get, right? And the other thing we can, well, okay, if x is negative 3, then we're raising 2 to the 0 power, right?
Yeah.
And that's going to give us 1. Okay?
And the rule still applies though. Like when you add whatever to the exponent, the x becomes less. But if you subtract,
Well, you got to use a lesser value of x. X actually becomes bigger when you add 3 to it, which is why x has to be 3 less in order to get the same value you would have gotten here.
and it applies for subtraction too. If you're taking away from x, it would have to become.
Yeah, x would have to be bigger. If it was if raising to the x minus 3, x would have to be 3 units bigger to give you the same value that you would get here. Okay? And we want to get these values because this is where the best picture of the function occurs. If we don't have the right values, if we try to evaluate this thing for x equals negative 2, negative 1, 0, 1, and 2, we're going to get something that looks almost like a vertical line with a huge scale out here. It's not going to show us the asymptote. It's not going to show us the x-intercept. The x-intercept, or the y-intercept, is not even going to be on the graph if we try to evaluate 2 to the x plus 3 for the values from negative 2 to 2. Okay? So, this means, of course, that here's the graph of f of x, right? But now these values all shift 3 units to the left, so that what we graphed between negative 2 and 2 here is now going to occur between negative 5 and negative 1. It's all going to shift over to that interval. So here we got negative 5 to negative 1, and our graph is going to do this. Okay? So, again, what we're seeing is we're seeing where the asymptote is, we're seeing where the graph starts to get really steep. Now, we also have to think beyond this interval to see, well, the graph's going to get really steep really fast, and it's going to approach zero really fast. So we want to think a little beyond that, but by starting with this process, we understand how the graph shifts, and that's going to be the same for any graph, for any function. F of x plus 3 is going to take whatever you get for f of x and shift it over 3 units. Okay? So, our original graph was like this. This graph shifted 3 units this way. Okay? So we want to, be sure we try to understand that as best we can and keep working at that. Okay? And if there's something you missed on the test or on a homework, you have many versions. You can go find other problems of the same nature with slightly different numbers and see if you can get those right, and you're welcome to say, hey, can you look at this? I'm not going to grade you on it, okay? Except if you do that consistently, I probably am going to give you a little bit extra, okay? I mean, if you're showing me that you're learning how to do this after you make a mistake, then I will be a little more likely to give you a better grade. Of course, you're making 3s on everything. I'm still going to make a note of it. And I'm going to make a note of, okay, doing all the right things, that's worth something. Okay? You got to trust me in what it's worth.